Okay, everybody, so in this video we are going to calculate some more long-term performance numbers. So within our data sets we already have the daily price value, but what we want to do is calculate some longer-term performance numbers. So 30-day, 90-day, 1 year, 3 year, 5 year, and 10 year are what we're going to calculate. So before we do that though, make sure you save off this candlestick chart script. So I saved it as charting.r, so make sure you do that before we move on. So I'm going to go back to our import and clean script, and I'm going to create a new section called performance calcs. And so the first thing we're going to do is we are going to create a data frame called performance summary. And to do that, we're going to say as data frame matrix NA and call equals 7 and row equals 0. So this is going to create for us a blank data frame with 7 columns, right? And so, just a reminder to what's happening here. First, we're creating a matrix, right, with 7 columns and 0 rows, and we're filling in the values with NA. The values aren't getting filled in because we don't have any rows. So, just to give you a quick idea, if we were to do 1 row and make this 5 and just run this matrix code, so just run this little snippet, right, we would see a 7-column matrix with 1 row and it's all 5s. So what we're doing is we're doing 0 rows and we're doing the value is NA. So next we're going to rename our columns. So performance summary, and we're going to create a vector with the names. So the first is ticker, then 30-day, then 90 days, 1 year, 3 years, 5 years. Let's capitalize the first letter of each column name, and then finally we'll do 10 years. Okay, so if we send that to the console, we open up our performance summary. We now have a blank data frame with our renamed columns. So what we're going to do now is we are going to loop through all of the tickers in returns long, and we are going to calculate the actual performance numbers over these time periods. So the first thing we need to do is we need to create a for loop. So we're going to say for ticker in, and what we're going to say is unique returns long ticker. And so what unique is doing is within returns long, the ticker is repeated multiple times. So we don't want the for loop to go for each version or for each entry in ticker, because then that would be several million rows, right? So what we're doing is we're just taking the unique rows in ticker. And so if I just run this little snippet here, you can see that we have our 500 tickers are in unique ticker, and we are just going to run through each one of these one at a time. So let's show that now. We'll say print ticker, and if we run our for loop, yep, it's going to show each ticker one at a time. Okay. So next what we're going to do is we are going to subset the returns long data frame within the for loop. So to do that, we're going to create returns long by ticker, and that's going to be returns long. We're going to use our piping function. We're going to filter ticker equals ticker. Sorry, that should be lowercase, so ticker equals ticker. Series equals close. And I don't think we've used this function before, but we're going to say range descending date. Okay, so now let me make this a little smaller. So now to go over what we just did here. So, right, the for loop is going to loop through all of the tickers. So let's say it's looping through, and let's say it goes to Amazon, or let's say it goes to Google. So GOOG. So what it's going to do, we're going to start with returns long. So let's go here. So we're going to put our filters on this dataset view, just so we can see what's happening. Right? We're going to filter Google. Ooh, and we don't want that actually. That class A share. Actually, let's use Amazon as an example. So let's say AMZN. Okay, so we're going to subset Amazon. Then we are going to subset the series by close. Right, so we're getting rid of high, low, and open. So we're just leaving it with close. And then we are arranging it by date value in descending order. Okay, so that's what we're doing to our data set within the for loop for each ticker. So then if Microsoft came up, we would do the same thing with Microsoft. We would start with returns long, and then we would subset our data set out. And so what we're going to do is we are going to calculate performance by looking at the value right in the most current day, and then we are going to look at the value right as to what it was a month ago, as to what it was 3 months ago, and so on. And then we're going to calculate the performance statistics that way. So let's get into doing that. So first thing we're going to do is we're going to create a variable called 30-day, and in open parens, close parens, we're going to say ticker, or excuse me, we're going to say returns long by ticker value, and we're going to say 1 minus ticker, excuse me, returns, man, if I could spell, that would be awesome, returns long by ticker $value, and we're going to say 21, and then we are going to divide this all by ticker by, wow, returns long by ticker $value 21. And so why we're using 21 is because there's actually 21 trading days in a month. So this isn't a true 30-day value, because this is just the average number of trading days in a month. So it's going to depend on the month, how many actual trading days are in it, but we're just going to use this as shorthand for now. And this is going to give us our 30-day this is going to give us our 30-day performance number. So let's just take a quick look at what that looks like. So if we say ticker, and I'm just going to do a quick example down here, so equals MSFT. Okay, so now our ticker value is Microsoft. So we're going to run the returns long by ticker, and I actually spelled arrange wrong here. Arrange. Okay, and so sometimes I like to do just this quick test within the for loop just to make sure everything is running. So now returns long by ticker is going to be Microsoft, right? Close, and it's arranged as we set it to be, as descending by date. And then if we calculate the 30-day performance number, okay, we can now see that it is 0.0047, or about 0.5%. So let's keep going. So let's copy this out. Let's copy this out 4 times. And we're going to say 90-day. We will say 1 year. And then let's say 3 year. So I'm stopping here because what we're going to do is the formula for 30-day, 90-day, and 1 year is the same. But for the 3 year, we're actually going to take the cumulative return, and then we're going to annualize it. So we're going to calculate what that cumulative return is on an annualized basis. So that's going to be a little bit of a different formula, so that's why I'm not filling out the 5-year and the 10-year right now. So let's work on the 90-day. And again, this isn't going to be exactly. I probably should have named these 1 month, 1 quarter, 1 year, but we'll just stick with this for now. So there's going to be 63 days in a quarter on average. So we'll change that to 63. And for the 1 year, there's about 253 trading days in a year, so we'll change that to 253. For the 3 year, there is going to be about 759 trading days, so we'll write that in right now. But this is going to create a cumulative return, right? So we want an annualized return, and so the first thing we're going to do is let's put our cumulative return in parens, and we are going to start this with actually another paren, and just one open paren here. Is that how we want to do it? Yeah, so actually let's do one more open paren right here, and we'll say 1 plus, and then this statement is going to be our cumulative return. And then let's put this whole thing in another set of parens, right? So this now is effectively 1 plus our cumulative return. So our cumulative return over this period, is going to be 1.71, or basically 171% return over 3 years. And we're just adding 1 to that. Okay, so now we're saying 2.7 here. And we're going to raise this to the 1 over 3, and then we're going to subtract 1. All right, and so what that is going to look like is we now have an annualized return of around 40%. And so if we were to basically multiply that by 3, so let's say 1 plus 0.0 or 0.39572. Let's put this in parens, and we raise this to the 3rd power, and we subtract 1, right? So that's getting us back to our cumulative return. So this annual rate multiplied, basically taken to the 3rd power, gets us back to our 171% return. All right, so now let's do this same thing for the other return periods. Let's copy this out. So we are going to change this value to 1265, and then in the exponent we're going to say 1 over 5, and then here the 10-year number is going to be 250 or 2530, right? It's just 2530. But actually, as you can see, I didn't pull enough data, so I only pulled 2518. Because I didn't pull enough in the original data pull. I didn't go back far enough date-wise, if you recall when we went on to Yahoo Finance in that first video. So I'm just going to change it to 2518. So I'm missing a few trading days, but effectively the 10-year number. So let's change this to 5. And let's change this to 10. Okay, and so we also need to change this exponent to 10. Okay. So now that we have all of our performance numbers, let's actually start putting these numbers into our performance summary data set. So let's copy out performance number, and we are going to say I1, and we actually don't have an I variable yet, so let's actually create that. So I equals 1. So we're going to place that before the for loop, and then at the end of the for loop, say I equals I plus 1. So what this is going to do is this is going to start out before the for loop where I is going to equal 1. Then for each ticker symbol, this for loop is going to run, and at the end of each ticker, right? So every time the ticker switches, I is going to increment by 1. So right now we're going to put I as the first argument in the performance statistic subsetting. So this is going to basically create a new row within the performance statistic or the performance summary data frame, right? It's going to create a new row for each ticker. So let's keep going. We're going to put in the first column, right? So the first column in performance summary is ticker. So we're going to put in our ticker. And so let's copy this out. We can paste it 6 more times. And then let's go 2, let's say 3, 4, 5, 6, and 7. And then let's put in 30-day, so that's the second column. 90-day, that's going to be the third column, and so forth. So 1 year, 3 year, 5 year, and our almost 10 year, right? So hopefully you guys took a little bit more data than I did originally. And then let's actually run out this for loop. Okay, oh, I didn't send my I variable. Okay, so now I have an I variable in my global environment, and now let's run it. Okay, so now we can see it's printing out because of this print statement each time this for loop gets run. And so I'm gonna let this run for a minute. I'm gonna pause the video here and I'll jump back in once this is run out. Okay, so if that ran successfully, you should now see your performance summary data set in your global environments tab up here. And if you take a look at that, you can see, right, it has 503 observations and 7 variables, and we can see that all of our tickers have our data now filled out. So some of the 10 years are missing, and that's okay because some of them might not have 10 years, right? Some of them might have been newly added or recently had IPOs, and that's why they don't have a 10-year, or maybe they went private and then public again. And some of them are going to be even shorter, right? So CARR doesn't even have a 1 year yet. So, and that's not going to be a problem. So R just put in NAs for those values, and we can deal with that in future videos. So let's actually save out this data set. Actually, you know what, first, before we save out this data set, let's actually join this to the S&P 500 data set. So let's see. Sorry, so if we go to performance log, what we're going to do is we're going to join this data set to the S&P 500 data set so that we can bring in the sector, industry, and some of that other information onto the data set. So to do that, let's load the S&P 500 data set. Okay, so now we have our S&P 500 data set in here, and let's use the function. So we're going to say performance summary equals performance summary, piping function left join S&P 500 by equals ticker equals ticker. Okay, let's run that command. Now if we look at our performance summary, we brought in the name of the ticker, the sector, the industry, and the HQ location. So we're going to use that in some of the upcoming charts and in the Shiny dashboard that we create in future videos. Let's actually save this out now. So we'll do save performance summary, file equals performance summary dot r data. Okay, so now if we go to our file viewer, let's go to our project, and now we can see we have our performance summary file within our directory. So that's it for this video. If you liked it, remember to subscribe. If some of these functions are looking confusing, like left join or the piping function, again, remember to go head over to my channel, check out the basic data manipulation in R video. It's going to cover these important functions. And in the next video, I think we're going to continue to chart some more of this data. We only have a few more charts to build, and then we can jump into building the shiny dashboard itself. And the next couple of charts should go a little bit faster because we already created a chart template, right, when we created this candlestick chart. So we kind of already have our template down, we have our theme down, essentially, and we can probably reuse a lot of this code just to create a couple of charts that are going to summarize our performance summary. All right, guys, thanks for listening.